Hi, everybody, and welcome to today's lecture. We're going to look at section 1.2, and I will share my screen with you. So here are lecture notes for section 1.2. And again, I'm going to go through them with you here in class. You should fill in all the parts that are missing. And of course, feel free to add in anything extra. So if we're going through and I mentioned something, but I don't write it down, and you want to make that note, definitely do that. Or make any notes for yourself along the way that you think would be helpful. The other thing I recommend students do is at the end of the lecture, just go back through your notes, spend just a couple minutes. And again, make sure you didn't miss anything and of course that you can read your writing. The worst is when you're trying to review and then a couple weeks later you realize you have no idea what you wrote down. So take those few extra minutes and add in any extra details you need to at the end of the videos. In section 1.2, we're going to review how to work with and solve linear equations, and then also introduce rational equations. We are going to come back to rationals throughout the semester, so we'll come back to those later on. But today, really, we're kind of reviewing those solving techniques, hopefully ones that you are used to or at least seen before. And again, we'll look at a couple more complicated examples, particularly those rationals. So in this lecture, we're actually kind of going almost a little bit backwards. So we're going back to just one variable at a time rather than two variables like we did with graphing. So here we're solving linear equations in one variable. And we're going to focus on the variable x, but of course, any variable would be fine. So a linear equation of one variable is an equation that can be written in this form here, where a and b are real numbers and a is not 0. Now, I will note that, of course, linear equations can look very, very different from this, but this is sort of a simplified version. But what you want to note in linear equations is that you're going to notice that there are no squares, cubes, etc., right? There's no roots. There's no dividing by variables yet. They're, again, your most basic form of your equation. So you're not going to see anything too weird going on. Now, to solve that equation means to find all values of x that make the equation true when we substitute them into the equation. And these are called solutions. So when you see the word solution or even the word root, those are used interchangeably. You want to think about those values that make the equation true. And again, this definition of solution goes for really throughout mathematics for any number of variables. If you have one variable or two or more, it's still that same idea of getting a true statement. So let's consider this equation here as an example, and we'll see that x equals -3 is a solution, but x equals 1 is not. So if I go ahead and I plug in -3, and I simplify, 4 times -3 is -12, and 12 plus -12 is 0. So you get that nice true statement here. So we do know that this is a solution. When I go to plug in 1, and I simplify, I have 4 times 1 is 4, and then 4 plus 12 is going to be 16. So this obviously is false, right? This is not true. These are not equal. So that was a false statement. So this is not a solution. Now we'll talk about this at the end of this section, but you're going to see that in one variable, typically we tend to see a finite number of solutions. So one solution, maybe two solutions. It depends on how complicated our equations get. For linear equations like we're doing here, you're going to either see typically one solution. At the end of our lecture, we'll talk about some exceptions to this. So there are chances where you could have more than one solution or you could have no solutions. But again, most times in this section, you're going to see one solution answers, which is different than when we were graphing and we had infinitely many solutions. All right. When a value is a solution of the equation, we say that that value satisfies the equation. So that word satisfies is another way to say we have a solution. And the set of all solutions of the equation is called the equation's solution set. And what you want to remember is when you're talking about sets, we do use this kind of squiggly notation. You don't want to use parentheses or brackets. It's very specific that you use those squiggles when you're talking about a set. And there's lots of different kinds of sets. So here we have a solution set. Now in the example above, what we are going to end up learning is that -3 in this case is the only solution. So we're going to solve our equations a little more systematically in a minute, but that's going to be the only solution. So we can write it like this if we want to be a little bit more formal. Two or more equations that have the same solution are called equivalent equations. So that word equivalent basically just means equal. And they're equal in the sense that they have the same solution. That's how they're equal. So for instance, equations like 4x plus 12 equals 0 and 4x equals -3 are equivalent because they both have that same solution set of -3, right? If I take this equation here and I plug in -3, I'm going to see that I do get that true statement again. So it's also a solution to that equation. Now, when we solve equations, we're going to use this idea of equivalent equations, and you can kind of see that these two look the same. So if you remember your solving skills, you're probably saying to yourself, well, this is how we solve. We start here and we go to the next step. And that's what we're going to do. But the reason that this works is that because we're making equivalent equations along the way. So we're never changing the solution when we're solving, even though we're moving things around or we're dividing or multiplying, the solution stays the same, and that's what's important. Now, when solving equations, they can be simple or they can be very complicated. So I just kind of wrote down some general guidelines here when you're solving equations. The first thing you want to do, and this sometimes takes the longest, is to just start simplifying. So anything that you can see to simplify, you want to go ahead and do that. For me, I like to start with parentheses first. If I see parentheses, I'm going to use that distributive property and multiply through. I tend to also like to clear fractions. We'll do some of that in a second. You can clear decimals or you can work with decimals. It doesn't really matter. When we have calculators, they're really not that bad to work with. And of course, you're going to combine like terms on each side of the equation. After you simplify as much as you can, there's sort of nothing else for you to do. Now you're going to start moving things around. So this is the collecting stage, I like to call it. So we bring all terms with variables to one side of the equation and all terms without variables to the other side of the equation. So this is when you start adding and subtracting on both sides of the equation to move things around. After all your terms are separated, you're going to divide. So at this point, you should have something very simple, like here, 4x equals -12. And now we're on step 3. So your last thing is to divide by whatever number is being multiplied by the variable. And we do that on both sides. And of course, you can always check your answer. And you can check your solution by plugging it back into the original equation to make sure you get a true statement. You do want to use the original equation though, because it will then check all your process. If you don't start with the original equation, then you risk missing a mistake you may have made. So we do always go back to the beginning there. All right, so let's do some solving together. There we go. So the first example we have, again, is just a very basic one. If you feel like you need to have those steps in front of you, go ahead and keep those off to the side while you're going through the lecture here, or even put them on an index card. That way, again, you can kind of keep it with you while you're doing the homework. But in this first example, I'm going to know that it's already pretty simple, right? There are no parentheses, no fractions. If I look on each side of the equation, so I'm just going to write this a little bigger. And you don't have to do this, but sometimes I like to just kind of draw a vertical line, write down my equal sign to show my two sides of the equation. And if I look on the left side, I don't see any like terms. If I look on the right side, it's just 17. So I'm ready to start going on to step 2 and moving things around. And we're still using this like term idea. So I would really like the 17 and the 3 together, but they're on wrong sides. So to bring the 3 to the other side, you have to do the opposite. If it's +3 on the left, we're going to do -3 to bring it on the right. 3 minus 3 is 0, so it allows us to cancel it on the left. The 2x is just going to come down. And then on the right, 17 minus 3 is 14. Now I can see that all my like terms are together. I have just a 2x on the left and just a +14 on the right. There's no more plus or minus signs. So my next step is to divide by 2. I want to get rid of this 2. And notice that it's being multiplied. So the opposite of multiplication is division. So I use that to cancel. Now 2 divided by 2 is 1, but 1 times x is just x. So notice that our last two steps cancel for different reasons. This one cancels because we have addition of 0, which doesn't change the problem. And this one cancels because we end up multiplying by 1, which doesn't change the problem. So you're canceling, but in two different ways. And I have x equals 7. Now to check this, I go back to that original equation, and I'm going to replace my x with my answer, which is 7. 2 times 7 is 14. Don't forget to follow the order of operations here. And 14 plus 3 is 17. So 17 is 17. This is true. So I know I did a good job. Looking at the next example, again, a little bit more complicated now. So I see lots of parentheses. I'm going to start with that first. You can't actually move this -3 or cancel it out if it's stuck inside parentheses. So we do want to do that first. So I'm going to multiply through by 2 here. So I'm going to get 2x minus 2 times 3 is 6. And then I'm going to bring down the -17. I'm going to just kind of stay lined up here with my equal sign. And on the right side, I'm going to bring that 13 down, but you do want to be careful. One second. There we go. I see a minus here. So actually, when I distribute that 3, I'm distributing a -3. If you want to, you can always change subtraction to adding a negative. And if that helps you to remember to distribute that negative, then go ahead and do that. So we're going to distribute that -3 throughout. So it's going to be a negative or a -3x. And then -3 times +2 is negative or -6. You're going to see in math that negatives and minus signs are pretty much interchangeable. So you're welcome to either use subtraction or adding a negative when you write your problems down. Next, I don't see any fractions or decimals or things like that. But I do see I have like terms on each side of the equation. So before you start moving things from side to side, look on each side and combine your like terms. So here I see a -6 and a -17. So I'm going to have -23. And then on the right side, I see a 13 and a -6, which is going to be 7. And then I bring that -3x right down. Notice that when I combine like terms on the same side of the equation, that I don't have to change the sign or anything. I'm not doing add 6, or add 17, add 17. If they're already together on the same side, you're just combining your like terms. Okay. So now if I look, I can't really do anything else. I'm ready to start moving things around. I have x's on both sides. I have numbers on both sides. So you can pick what you want to do. Most people tend to like to bring their x's to the left when they have a choice. So I'm going to follow that, but it doesn't matter. So if I bring my x's to the left, I'm going to take this -3x and make it a +3x. Right? This is different because I'm crossing over the equal sign now. So I have to use that opposite idea. So I have 5x minus 23 equals 7. And then now I'm going to bring that 23 to the other side. So it becomes a +23 to get it to cancel on the left and move it to the right. So I have 5x is equal to 30. What you want to notice too along the way is I'm just trying to keep myself lined up. You don't want to mess up where that equal sign goes. So that's a way that you can cause a mistake for yourself. So just kind of keep nice and organized. Notice all my terms are combined. So my last step is just going to be to divide by 5. When I divide, you're not changing signs. Use the exact number that's there. So I'm dividing by +5. That gives me that 1. And then x is equal to 6. Now, let me check one more with you guys just to kind of go through the process. You do have to go back to the original problem if you're going to do the check. And I'm going to replace that x with 6. You can also do your checks mentally. And this one's a little bit harder because it's kind of a long problem. But for the easy ones, you can even just do a mental check and make sure the answer comes out right. Now, with order of operations, I am going to simplify inside first. So let's say I have a 3 there. And there I have an 8. Then I'm going to do multiplication. So I have 6 minus 17. And then over here, I have 13 minus 24. 6 minus 17 is negative 11. And 13 minus 24 is also negative 11. So because this is the same on both sides, our answer is true. And we know our answer here is correct. Now, one thing I will note for you guys, if you find that your check is not working, I would have you check your check first. A lot of times students rush the check and they end up making a silly mistake here. Then they think they're wrong and they go back and they start everything over. So if you're doing your check and it doesn't come out to be a true statement, check here first. Make sure you didn't make a silly mistake or miss a negative sign or write the problem down wrong or something like that. And then if you're still finding that it's not working out, then go back and check your work here. The other thing I encourage you to do too, as you're going through your homework and everything, is don't erase stuff. So a lot of times students will do work and then they'll just erase everything and start over. I would recommend maybe crossing out or getting a new page, because sometimes when we erase, we actually have some good information there that you could use for the problem that you're working on. So maybe you actually realize like, oh, you only made a tiny mistake. And you erase the whole thing, right? So try to maybe just use extra paper or do more work off to the side, I recommend, rather than erasing everything. Unless you know that it really is totally wrong. Usually it's good to save work. It's a good learning experience. All right, one thing I do want to be note is do be careful. So we do have expressions and equations. Expressions do not have equal signs and they're simplified. Equations have equal signs and are solved. So you just want to be careful. So something like an expression looks like this. There's no equal sign. So what I would do is I would simplify. Here, when I distribute, I'm going to make sure I distribute that negative as well. I can combine my like terms. But that's as far as I can go. So with expressions, we're typically just simplifying. With an equation, you have an equal sign. So now you're actually solving. Notice that we still end up starting the same way here. I'm still going to simplify on the left side. So I have that negative 2x and the negative 10. But now I'm going to take it further and actually solve. So now I would go ahead and add 10 to both sides and divide by negative 2. Okay. So you just want to be a little bit careful. A lot of times we use those words interchangeably, but we shouldn't. Expressions and equations are different things.